All right, so it's about that time. Russ, if you will do a quick intro for Bruce, although I'm not sure he needs much of an intro. Most folks already know him.
Yeah, so for everybody, I think it was probably, maybe 6, 8 months ago, Bruce did a live presentation, if you will, at one of our meetings that went over very well. And I know a lot of you have met him at my ops session. So today he's going to have part 2 of that. And so Bruce, thank you very much. And we'll let you press on.
Well, thank you, Russell. First of all, thank for both Fred, Ron, or all three, Fred, Ron, and Russell, for inviting me to come back to do this. I'm taking this opportunity first also to congratulate those who have shown their models. And being primarily a modeler, I appreciate looking at other folks' models too. And as Russ mentioned last year when I did this in person, I walked over to the corner where the tables were and I was very impressed. And I'm sorry you guys can't bring them out in that kind of format right now because of the virus caper. But anyway, congratulations to those guys. So part 2 here, I'm going to build a little bit on what I showed you last year. I'm going to pick out a few models here and not go really into the construction of the model, but how some of the details or how some of the decisions were made and what kind of materials I used to bring the model to its final presentation. And then I'm going to go into some new things I've done since that time. Models I've made, one diorama in specific that I worked on during that time. Just an example of some of the things I do and how I make some of the models that I've created. Okay, some of the first ones. I made a model of a permanently coupled TOFC car that the Santa Fe produced. It was in the FT class. And once again, to refresh, Santa Fe classified their cars by the first and last letter of the name. So FT is flat car. These cars were originally of the FTM classification, and they were single cars that were configured for a 40-foot trailer, the cars themselves being 44 feet long. Well, that meant each car and each trailer was its own separate shipment. So Santa Fe said, this great idea, let's couple 2 cars permanently together with a drawbar, and now we can ship 2 trailers as one shipment. So that's the car I decided to build. The basis of it was some Sunshine model FTM car kits that have been heavily modified and changed in several ways to make this model. One of the other detail things I had to work with was the style of trailer hitch. And this comes from GATX, which was also in the car and trucking kind of realm. There's no commercial model for this hitch, so I had to dig and scrounge to see what I could find to make it. And that led me to Details West, and they make several hitches, but I looked at these 2 in particular because they had the parts that I needed to replicate the GATX hitch. Off of 0007 here, I took the base and had to file it down smooth. And off of 0008, I used the vertical stand, the trailer hitch plate, and then significantly modified the brace in the back to recontour it to represent the GATX hitch. And these are pewter models here, so they're metal to work with, and it's pretty easy with files and things like that. There's the hitch as modified, and it doesn't really show up in this photograph, but the whole back of the angled brace here has been cut out to match the prototype hitch. And then using some photographs, I used styrene shape and strip stock to make the rest of the framework that went around and supported the hitch. And of course, I had to make 2 of these because one car had 2 trailer capability, 2 hitches. Other detailed parts that pretty much had to all be scratch built for this car went on the deck and the sides. And first of all, the stanchions. There's absolutely no model of that anywhere in the world. Now with 3D printing, this could be something very easily made, but I made this model back in 2008, and that wasn't in the realm of possibility at the time. So I worked with several materials and ended up using brass I-beam stock that was cut, bent, filed, and shaped to get the form or the shape of this stanchion that needs to go up and down the side of the car in the stake pockets here. And I got that information from, this is called a folio sheet, and that's the Santa Fe's name for it. Other railroads, I'm sure, had other kind of information sheets like this that would have the details about any specific car. And other things we can find on these here. We get a lot of dimensions, we get weight data information, we get information about, for example, the style trucks that went under the car, things like that that are good to look at for modeling aspect as to what am I going to use to finish or make this car. The box I've got outlined in yellow there had the dimensions for the width of the deck and all the appliances that went on it. So you can see I did the math and I got the contour I had to make for the stanchions. I was able to determine that the rub rails for the tires on the truck trailers were 4.5 inches in diameter. And if you hold that thought for a minute and divide that by 87, I'm going to show you a number. It gave me the height, it gave me the width, it gave me everything I needed to do to finish the sides above the deck for the flat cars. Okay, vertical post. It's like when you come up the steps on the end of the car there, you needed something for the crewmen to hang on to. They were styrene H stock, and I just took 15 thousandths brass wire and bent it to make handrails for it. I did that so they'd all come out uniform. I made a jig, again, using the dimensions on the folio diagram, and I used styrene H stock here because it was a lot easier to work with for making multiple units than brass would have been. So I cut the jig there, and then I would cut the styrene H stock partway on the web and partway on the flange to make a little V cut on two sides so I could bend it to match the contour of the jig here. There's the base, there's the angle out, and there's the rest of the vertical. And I tacked it in place with T-pins and then put my styrene cement on it, gave it adequate time to dry, and I was able to make up 8 of those tall pieces there to allow the crewmen to climb up and get on the car if necessary. Tire rub rails, divide 4.5 inches by 87 and you get 0.05 and change. So that dictated 0.05 brass rod. On top of the stanchions, originally the railroad used old rails, and eventually as they converted more of these cars, they switched to another type of tubing. But since I chose by the side number an earlier car, I put rails on top of mine, and that truly is the prototypical way it was done. The extension, the cars permanently coupled together, remember, they needed an extension on the deck to facilitate towing the trailers up and down a string of the cars. So they extended the deck out a little bit, and then on top of it, they put a diamond tread plate pattern that covered the gap between the cars. And it turned out Plano Model Products makes this product. It comes in a sheet about 1.5 inches wide and maybe 6 inches long. And it was a simple matter of cutting and then filing it to get to the correct shape. And you can see there's one of them right there that spans the gap between the cars. Here's a side view of the same thing. There's that diamond tread plate. Now this one looks skewed out of place a little bit, and I'm not sure if it was broken or that's the way it really was. But the other thing from a modeler's perspective, I needed something to fill the gap between the ends of the existing cars over where the permanent coupling underneath was. And it appeared it was a metal extension that went about 1/3 of the way out from each car, and then a heavy canvas type material. And I couldn't pin it down for sure, so I just said, it's gotta be canvas. Well, to replicate that for the model, there's a photograph actually with the canvas intact there. I said, how thick is a piece of canvas in 87th scale? What I ended up using was a piece of styrene to extend the sill out, and then a piece of paper just glued to the back of that styrene that would fill the gap. And here's a photograph of what it looks like. There's the extension, there's the piece of paper, and it was done on one side of each car only, the right side where the cars met. Here you can see part of that permanent coupling I fabricated. There it is put together. So I've got my 2 side sill extensions, and I've got my flexible material in between there to allow for the cars to go around curves and yet have the ability to keep that gap covered with a flexible type material. So that's pretty much everything that went into that. Underneath, we can see, and I showed you this part last year, oops, there's the permanent coupling, and it's on 2 big bearings, so it'll swivel up and down and laterally as it goes over the track. And I also put a permanent brake hose between the 2. They didn't have brake hoses that you connect each time you put the cars together. And once again, there's the finished product, an FT16 trailer on flat car. Next, I showed you this, FE, furniture. Generally, they were 50-foot, generally double-door box cars. This one was unique, and it was the first car Santa Fe made like this that had 2 different style doors. It had a sliding door, and it had a close-fitting, what we call sliding plug door. And there was no commercial model of this kit available, so I worked with a couple of branch line car kits, some scratch-built parts, some additional doors, and a bunch of details also to create a cushioned underframe under this. This car had 4 firsts for the Santa Fe. First with 2 different size doors, first with a cushioned underframe, first with the red and black paint scheme, and I forget what the 4th one is, but that was all last year. Anyway, the other part that was unique to this car is typically the freight cars have the reservoir, air reservoir for the brake system on one side of the car, and on the other side, they have the brake control valve and the brake actuating cylinder. This particular car, because it was early on in the development of cushion underframes, they hadn't figured out how to do the piping, and they said, well, it'll be real easy if we do it all on one side of the car. So that's what they did. So that's another feature I replicated on my model. I put all 3 of those brake system components and the air piping that goes with it, put them all on the same side of the car, the way the prototype was done. And that was easy to do. Other things I did at the end, I put the extended coupler pockets on to replicate the cushion underframe. There's a shock absorbing brace that I replicated here, and all the piping that you would normally see on the end of the car also, including a unique way that they routed the retainer valve piping. Sometimes it goes on the inboard side of the brake wheel, but it goes behind the step. Some car manufacturers put it on the outside and run it down here. This particular car, they put it inboard of the brake wheel system, but they routed it around the brake step. And I did that on my model also. There's the brake retainer valve plumbing going down to the bottom and then under the car. And I actually built 2 of these cars. It took quite a bit of hacking on the original branch line car, basic car kit. And I said, if I'm going to do that much hacking and whacking on it, I'm going to build 2 of these rather than just 1. So there's that. Another one is Santa Fe had some refrigerator cars. These were eventually all dubbed USAR USRA, excuse me. And I'm going to talk more about some of those in the later portion of this. But Intermountain made a model of that car. It was pretty basic. And if you look at all the different ways the Santa Fe configured the car, there were quite a few differences. 2 classes of this car in the RR, and RR is refrigerator, R in the beginning, R in the end. The 21 class and also the 29 class had an early cushion underframe made by the Duryea Corporation. And rather than using hydraulics or spring systems, they used friction with wedges to try and eliminate some of the shock when cars were coupled together. And again, those were the RR 21 and 29 versions. The basic car body from Intermountain was almost perfect for this car, but the underframe is what needed extensive work to make it into a correct model for these kind of cars. All right, Speedwich Media, company that produces urethane castings and car kits. They make kits for Duryea underframes, and that became the modification basis for this car. Using the Intermountain frame, had to clean off all the braces and supports and cross bearers that were there to allow facilitating installing the Duryea underframe, including 2 of the main cross bases were hollow in the middle, and they went all the way up through the bottom casting of the floor of the car. So I had to fill those in, and it became a simple matter of a piece of strip styrene cut and sized to fit in that gap to retain a full, complete underframe again. And then using the kit parts from the Duryea underframe, there's what the underframe looks like completed underneath the car. And some folks say to me, Bruce, why do you do so much detail on the bottom of a car when basically no one ever sees it? And I think it's my way of making models. I like to make them as complete and accurate as I can. And if this is what the original prototype car looked like, and I was modeling this car, this is how I want it to be completed. So that's what it looks like completed before putting it together, including some of the friction devices were here at the draft gear and some were doing through the length of the floor. And these had slightly extended draft gear or coupler pockets on them too. Not like you see on cushion cars today, but they were slightly extended because of the need for the cushioning in the system. And there's the completed car as it turned out. And this is modeled after a real car. I have photographs of 20269 completed, and this is how it was painted. And a quick note, we'll see it more later here. I model in 1967, so this This was an older type car, but it was correct in appearance and configuration for the late 1960s. Some of my cabooses, I've gone to the extent of putting lighting marker lamps in. And some of you may know or remember, but if not, I'm a DC guy. I have never made the transition to DCC. With DCC, we can have a constant track voltage, and we can put an electrical circuit in that takes care of a constant regulated voltage for any kind of electrical accessories. Well, I needed something that would work with a variable voltage DC system, a straight DC system, in order to make the marker lamps work. And these marker lamps, inside, they're 1.5 volt grain of rice bulbs. They're very tiny, but they're only good for 1.5 volts. Turns out Tomar themselves makes a little wiring diagram on how to make an electrical circuit that works with DC. And it needs two things. It needs to drop the voltage significantly to get down in 1.5 volt region, and that's the job of the diodes. And it needs a ballast lamp so it limits the current flow. I don't get a bazillion amps going through this circuit and blowing up the little bulbs in there. So I'd made this, and I thought even more. I said down at the bottom there, if one ballast lamp is good, two have got to be good too. So there's the little electronics package I made. You can see down here we've got the wires that I bring up from the trucks, and I'll show you a little bit more about that in a couple slides. There's the diode pack, and you arrange the diodes 2 each in parallel and 2 pairs each in series. No, I said that backwards. You want 2 in series. You do it here with the mouse. Those 2 are in series, and then you reverse 2 more and you make them in parallel. And that allows the voltage to go in either direction. Because remember, when I change the direction of a train or a locomotive and make it go in a different direction, I have to change the positive and negative relationship of the voltage on the track. So this diode pack takes care of that. Voltage can go through this way or it can go through this way. It doesn't matter. There's my ballast bulbs, and they're painted so that no light comes out of them, and they're attached to the metal weight for the car, which also doubles as a heat sink for the heat generated by the ballast bulbs. And then you just run the wires back up, and they end up going inside the car, marrying up to the marker lamps. Now the trucks. Katie, I know, makes some, and maybe somebody else does, electrical pickup trucks. And I said, well, I'm here at my workbench. I'm not at the hobby shop. I don't want to wait a week for them to be ordered if necessary. I can make simple pickup trucks myself. And I did that by drilling a hole, 2 holes through the bolster and fitting it with 0.010 phosphor bronze, start all that over, phosphor bronze wire. And I made sure that they rubbed with sufficient pressure on the axles. Now, generally, if we're using a plastic or a Delwyn framed truck, we don't need to worry about polarity of which insulated wheel is on which side. In this case, of course, you do, because I don't want to have a short circuit through the lighting circuit inside the car. And between the 2 pieces of the wire, I soldered a small brass strip, and up from that comes the wire that leads into the side of the caboose that brings the power up for the electrical circuit to power the marker lamps. And there's everything all installed in the car. All I had left to do was put the roof on the cupola and the roof on the forward portion of the caboose body, and I had a finished car. All right, now the new stuff. This is stuff I've worked on since the last meeting, and we'll see what I've got involved in here. A whole bunch of years ago, I was in a hobby shop. Turned out it was down in Gulfport, Mississippi. I was visiting a friend, and I saw on the shelf Santa Fe test car kit. And it's from Walters, and I said, well, I'm familiar with these. I got it home, and I dug out my work equipment book from the Santa Fe Society, and I checked it out with the prototype, and it checked out really well. Everything seemed to have good fidelity to the original prototype. I enhanced the model, as I do with many of them, with, it has cast on features. I'll remove all those kind of things, and I'll put separate detailed parts on them. Okay, I've got a scale test car. They just didn't run around the railroad by themselves generally. What did they have that went with them? Well, last year I showed you how I built a scale tool car that travels with the scale test car. And there's a quick photograph of it. There's the prototype on the left, and there's the model I built. And that came from a Westerfield kit. In their Santa Fe series, again, BX is box. The car was originally built as a BXO, And when they had enough car classes and I got up to Z, they switched to numbers. Those BXOs were modified and upgraded over their life. They became BX5s. And then they were upgraded again later in life and they became BX14s. And when it got to the end of its revenue service life, Santa Fe chose to convert some of these into WX14s. And here's the one oddball. Work equipment, WK, would be the logical way to do it. And for some reason, the Santa Fe made them WX cars. All the cars in the work series, no matter what kind of car, is a WX. Who knows? But anyway, that's what it turned out to be. And there's my model of it on the right, along with the scale test car. And so now I had something I could reasonably put on the railroad. I had a scale test car and a tool car that would travel with it. Okay. If it's not running around in a train on the railroad, what do I do with it? Well, I got to stash it someplace. I could have a track in the yard to park it on or something like that out of the way when it's not being used. I thought to myself, well, how about a model scale in my yard? And that way I could have the scale test car and the scale tool car sitting there doing something for real if I wanted it to. So I had some space next to a ladder track in the yard and I started digging out the scenery. And in this portion of the railroad, the yard end here, the basis for this is a sheet of plywood with a full sheet of homosote over the top of it. And my scenery is drywall compound and sometimes a little sand mixed in with it to give texture. So with a scraper and a putty knife and stuff, I started to dig out where the scale track was going to be placed. I had to splice in a turnout at both ends. Back up just a bit there. You can see at the far end there and the near end, both ends of the scale track there. Okay. I hope I'm not the first guy in the world that thought of this, but to match the existing curve of the track that leads into the yard, I was able to cut on the bottom of the turnout. And this is a plain old Shinohara number 6 left turnout in this particular case. So I could flex it a little bit and bend it. And as long as I kept a track gauge on top of it while I was splicing it in there, it maintained the true curve there. So instead of having a little short stretch after the points, it worked out that I could match the yard curvature there. And it ended up looking pretty good, I thought. So again, I hope I'm not the first person to ever think of cutting track to make it bend. There's both ends of it there in place. And in order to get the rails for the scale, they are termed live rails, which are the ones that actually bear on the scale table, and dead rails. So they are the ones that pass over the scale but are not supported by the scale. A friend of mine had some Fast Tracks tools and he made the points for me. You don't need a frog or anything in this case. You just need a stock rail that you cut out and a point rail that will flex and bend in with it. So I put those at both ends of that. And now I have a fully functional set of rails that service the scale or pass over. Scale itself is made by a little sheet of styrene, and over the top of that I used basswood strips because most scales seem to have a timber deck on them, and over that the rails were laid, and that gave me the finished scale. While I was working that day and taking the pictures, I had a lamp positioned over there. That was enough light that I could see what I was doing and take a photograph. All right. What would a scale be without a scale house? You need someplace to put the scale itself. I had a couple photographs available of the Santa Fe scale house in Chanute, Kansas. And I said, well, this one looks pretty good. I can make this for my scale house. But I didn't have any dimensions. But knowing that most doors are 6.5 feet or 78 inches high, that gave me something to work with to discern the dimensions for everything else on the scale house. And that's what I used. I used styrene, I used commercial available windows and doors. I made a scale house, I made a roof, and I even made a scale table. And they had, sometimes in those days, they used one of those balance beam scales. It wasn't digital or anything like that. The guy slid weights along it to come up with the weight of the object being weighted. And there's what it looks like all finished. And you can even see in there, there's my scale table that the worker would work on to use to weigh the cars or whatever was being weighted. Scale was about 50 feet long. When later cars that were longer than 50 feet came along, I found out they would weigh it in 2 segments. They would push one truck, one end of the car, exactly halfway onto the scale, weigh it, and then push the car further across the scale, exactly halfway, as near as they could determine, and weigh that end and add the 2 numbers together. Now, all the stenciling, every car I've ever seen, it's weighed to the nearest 100 pounds. If they're off by a few here and there, probably no one will ever know the difference. So there's the completed scene. There's my track I had to lay. There's the scale table, the scale, and the scale house all in place. Points are functional, like I mentioned. I can use either set of rails. They're both electrically live, so I can move things on and across the scale. And that's what it looks like pretty much all finished up. Scale, scale test car, scale house, scale tool car. You can put some people, God, it's jumping all by itself. You can put some people around it and you get a nice looking scene there of what's going on at the scale. All right, I have a scale test car, a tool car, a scale house, and a scene with the scale workers in it there. Does anybody think I've completed the work on this project? And you don't have to raise your hands or holler or anything, because I know some of the answers are. If I ask you that question, I'm going to give you a hint of what I thought of next. All right, 2018, the Santa Fe Railway Historical and Modeling Society convention was held in Chicago, actually out in a town called Naperville. And I thought this scene might make a good diorama entry. So I got a block of masonite and some wood framing, and I made it up to the specific dimensions they say that you can use for a diorama. I started to install some of the track on it. I started to put, I painted the rails and the ties and started to get ready for some scenery with my same drywall compound I used on the railroad, and had a provision in there. I was going to put a little building down in this corner. Well, my thoughts changed in that along the way, and we'll see here in a second what happened. There's what it looked like all finished and put together. Main yard tracks, or whatever you want to call them. My tracks leading up to the scale with all the provisions here: test car, tool car, scale, scale house, work crew. And down here, I decided to put a section house, and I got a speeder. This is a Santa Fe phone booth, believe it or not. Inside that little hexagon-shaped structure is a telephone that was scattered around various parts of the yard. So there's all the pieces that went with it that completed the diorama. And that's what I took to the convention and entered into the contest. Another view of the same thing there. The phone booth actually is American Model Builders. That's a laser cut kit and painted in the what they call colonial yellow and reddish color, the red zinc chromate primer that they used for a lot of their structures. Okay, now do you think I'm finished with this project? And of course, the answer is yes in this case, unless someone comes up with another idea of something I should do to enhance it anymore.
Hey, Bruce, we got one question for you. Are there any restrictions or guidance pertaining to where the scale and the tool cars go in a train when it's moving?
What I found out from Santa Fe literature was they wanted the scale test car itself to be the last car in front of the caboose, or no further forward than the second car. In that photograph I showed you, it was in front of the scale tool car. Some other unique things about scale test cars: they don't have brakes on them. They have an airline so you can pass the brake system air through to whatever's behind it. But they don't have brakes, and this kind of is ironic to me. They don't want to alter the weight of the scale test car much. It's set to a standard, so when I put it on a scale, they'll know exactly if the scale is calibrated correctly. Well, the wear on the brake shoes on a scale test car, I can think imagine could be measured in a couple of pounds for all the brake shoes. And if we weigh cars and equipment on the scale to the nearest 100 pounds, who's going to know a couple pounds of wear on the brakes? But the other thought might be that this car, even though it might be fairly heavy, is only running on 4 wheels. They don't swivel underneath the car. It's enough distance or enough slop in them that they can go around curves and through turnouts and not derail. But again, back to the question, just like the picture I showed, they run at the end of the train. They are not designed or built for having large loads behind them.
Cool, thanks. And for a time check, it's about half an hour in.
Okay, and here's where I put my question slide in. Any breaks at this point, if you want to contact Fred, Ron, we'll take more questions, or we'll have a question break at the end also. We can go over any other questions. All righty. Further along in the new projects. In World War II, gondolas were built, many cars were built, boxcars even, hoppers, with wood sides to conserve steel for the war effort, for making ships and tanks and airplanes and whatever else steel was used for. And the Santa Fe was no exception. Back during the war, they created a GA gondola 61 class, and they had wood sides like everything else at the time. Some of these cars got new metal sides after the war. Some lasted incredibly long to the end of their life without having the wood sides replaced. And here's two dated photographs. Here's a car, 176698, photograph was taken in 69, wood sides. Here's 176682, July 72. They still had wood sides. So I said to myself, Sunshine Models makes a kit, a wood side gondola of this GA61 class that would be appropriate to make and put on my railroad. And I could identify at least two cars that were dated, photographs dated, that would prove that these cars still had wood sides at the time. Sunshine kit, pretty much straightforward assembly there. There it's all put together, primed. Open top cars sometimes can be a challenge to put weight in. And sometimes the load in or around the car is appropriate to conceal the weight, and I've done that with several other cars. Other times I've used small lead shot glued into the underframe of the car, not visible from the side, and put in separate from all the brake system rigging and everything that brings the car up to the appropriate weight standards. And the kit, even though it's made from gray urethane, it came with wood side, interior sides, and a floor that could be finished to make it look like it belonged in a wood side car. The exterior of the car, the sides here, they had wood grain cast in. That was part of the original model. So I didn't have to mess with the outside to make it look like wood. It was just the inside. And there I did it. There's the finished car. And you can see even inside the wood grain, the long sheet or the long pieces of wood, strips of wood that made up the side to replicate what it looks like on the outside. And this is car 176698, exactly as it was pictured in that photograph. I really messed up the interior to make it look like it was well used. I don't know if that was the original World War II floor that was in there or whether over the years Santa Fe replaced them as they wore out. But that's what I made the inside look like on this car. And to give it some flexibility, I decided I could make a load for this car too. And we saw one of the other examples when you were showing open top loads a while ago. I made a tie load for this car. And down at the bottom, I used just a couple sheets of wood just so I didn't have to use so many ties. And then over the top of that, I glued all my railroad ties. And I intended to take a picture before I started staining it, and I forgot. And I got a couple brush strokes worth of stain on it. And I said, I'll take the picture now so I can look like you can see how the load was constructed. And there's the finished load. And there's the finished load dropped into that wood-sided gondola car. And the load's removable. All I do is turn it upside down and the load drops out. So, and I actually found a second one of these. I did make two of these cars too. I got a second kit and made another one, both with tie loads in it, fully replicating what the prototype would have looked like with that. I'll call this one the tale of two refrigerator cars. And I have a dedicated refrigerator car train. It's a block of refrigerator cars I run on my railroad. But let's talk about history first. In the 1920s, the Santa Fe acquired 8,000, big number, 8,000 of the USRA style wood refrigerator cars. And they were built in separate classes, separate groups, but the classes extended from RRX, once again, refrigerator X, they got up through Z and they started using numbers, the RR4 class. And there's a picture of an RR4, wood sides, wood roof. We're going to talk extensively about these kind of hatches they used back then. And good, healthy underframe. Here's an RRX car, and this shows the underframe better. These cars over their life were upgraded starting in the 1930s when they were barely 10 years old, the 1940s, and even again in the 1950s to keep them current for use on the railroad hauling perishable commodities. Some of these cars lasted into the 1970s, giving them a 50-year service life. with upgrades to make them last that long. Part of the reason that they could last that long was the quality and the durability of what was called the USRA underframe. It was a deep fish belly underframe. It was very rugged. It supported a lot of weight, and it was very durable. Over the years, though, the bunker drains at the ends of the cars dripped, sometimes water, sometimes salt water, down through and out these underframes. And a lot of corrosion and a lot of deterioration occurred. So during the 1950s rebuilds, a lot of these cars got new underframes. Now, one general comment here, all the upgrades that were applied to these cars, not every car got every upgrade. I'm going to show you that big difference here of these two refrigerator cars we're going to talk about. Some did not receive this underframe because it didn't require it. The original underframe was still in good enough condition. And some of the other upgrades were applied to the majority of the cars. So we can see some differences as we go down the road. When these cars were rebuilt over their life, they were reclassified into the RR19 through RR48 classes, from the original RRX to RR4. All right, here's one of them. And this is the car I'm going to build here. This is in an RR43 class. It's in its final configuration after its 1950s rebuilding, and it was car number 8996. Sunshine Models, long out of business, unfortunately. Martin passed away a bunch of years ago, and no one has picked up. His wife decided to end the business, didn't sell it to anybody. Resin Car Works, which is Frank Hodina, who used to make patterns for Martin's cars, now does make a model of this car. But the car originally had the original equipment as it was originally built. It had the 5-foot swing door, and it had reversed hatch covers that opened towards the end of the car. Now, here's where I'm going to give you a little discussion about this. Let me back up again. Somehow when I touch my mouse, it jumps. This car has had a 5-foot door. It's now got a 6-foot sliding plug door in it. And these hatch covers are now what's called standard hatch covers. They hinge and open towards the center of the car. Okay, moving on to another one here. Here's another RR43, exactly the same class, but it has some of the original features. It has a 5-foot swing door system, and it has the original reversed, what they got to be called, hatch covers. And this little piece of metal here is a brace that when the hatch is fully open, it opens only to about 20 degrees past vertical. And the car has a wooden platform on it for the worker to work on and stand on when the ice conveyor comes along and they're dropping ice into the ice bunkers. So here we have a car, same class as the last one, but it did not receive all the upgrades. It doesn't have the standard hatch cover. It's got the original reversed, and it maintains the wood platform, and it retains the 5-foot swing door system. All right, some of the features. I went over some of these already. Hatch covers, standard new ones on the car. Second car, 9037, still retains the reversed hatch covers. A new door on 8996, original door on 9037. Both cars got sill reinforcements at the sides because the original cars had wood sides. These now have metal sides, and it needed some more bracing to take care of the extra weight. Both have a sill reinforcement, but they're of two different styles. The car with most of the upgrades has an early paint scheme on it, and the car with none of the upgrades has a new paint scheme on it. Post-1958 scheme, which incorporated the large circle cross emblem instead of the small one, and different type lettering on the body there. And the original cars had roof panels replaced. They both have new rectangular panel roofs on them. That's the same between both cars. So I looked at this. I said, we have two cars in the same identical classification, RR43, different in appearance, different in configuration, operating at exactly the same time. So I said, I'm going to challenge myself here. Let's see if I can build these two cars. For anybody that's not seen or worked with a gray urethane Craftsman style kit, this is kind of what it looks like coming out of the box. It's cast in sheets, and the sheets might be a couple inches wide and as long as the parts that go on it came from there. This one in particular, they put the sides and the ends on one little sheet. They put the roof and some of the hatch hardware on another sheet. There's a casting of the underframe of the car. And there's the sheet here that has all the detail parts. We can see the coupler pockets here. We can see hatch covers. We can see the hatched latches. We can see parts of the underframe bracing that goes there that will fill in along the sides of the central frame here. Brake components, ladders, hoses for the brake system, a set of decals. And in the case of the newer cars, they had the walkway replaced with a metal walkway, and depending on whether you had reversed original or new standard hatch covers, a grating that would go over there. So that's what the kit looks like to start with. Car 8996, this is the one that received most of the upgrades, including a 6-foot sliding plug door that had to replace the original 5-foot swing door. Some of you have known me for a while. For more than 20 years, I have been upgrading the quality of my rolling stock. I started with, like most everybody else a long time ago, Blue Box Athearn, Varney, Roundhouse, pick a name, any name. Along the way, I had a lot of AccuRail. And for my refrigerator cars, I pretty much settled on C&B shops, along with some from Intermountain. Well, to make a car with a 6-foot sliding door, I had to have some donor doors. You can buy these, but I had some C&B shops refrigerator cars that I was replacing. And one of those cars became the donor for the doors for the new RR43. To get the doors in, I had to cut out the existing 5-foot door and enlarge the opening to accommodate a 6-foot door. Cutting the side was a rather risky business, because if I cut the entire door opening at once, all I would have left is a piece of urethane approximately 1/8 of an inch wide, holding the two halves together while I worked on cutting and filing and sanding. So the way I did it is I cut 2/3 of the door opening out up to here, and then I glued a piece of strong styrene behind the opening, maintaining the exact square level relationship with all the parts of the door, and then went in and cut the rest of the door opening out up to the top to accommodate the new door. And it looked like that when I got it all done. That bar across the back, no one will ever see that. That's on the interior of the car. So there's the new door spliced into the car's side that I was working with. And there's the pair of them all put together with the rest of the hardware, the door rails for the sliding door. I got ladders, I got grab irons, I got steps. The end grab irons don't go on yet, because on these particular cars, one end was anchored to the side, one end was anchored to the end of the car. And so I had to wait till the car was completely assembled in order to put those grab irons down there. On the roof, standard hatch covers or reversed hatch covers. This is the roof configured for the reversed hatch cover. It had the opening, it had the rest here for that small angled piece of steel I showed you, that when the hatch was open, it hinges here and here. When the hatch was open, it rests on that to hold it in that 20 degrees past vertical. It has supports for the walkway for the worker to stand on while they're loading ice into the car. I had to modify that hatch to represent, or the roof to represent the new standard hatch cover, which is now in place. Standard hatch cover, there's the hatched latch. There's some rests for when the hatch hinges here and here. The hatch hinges fully 180 degrees open to allow access. That was done, part of the reason this was done to change the hatch covers, when mechanical icing machines came along, they had a big chute that was on a control device that went down the length of the refrigerator car train and dumped the ice into the open hatches, and then a worker just came along and would close and latch the hatch shut. If you had a car with the reversed hatch covers, where the hatch cover kind of stuck, let me back up and find a picture here for you. We can talk about this better. If this hatch was almost straight up and the conveyor in the system with the ice on it came along, dumped the ice into that bunker, the hatch or the ice machine had to go up, over, and back down to get to the next car. Whereas if the hatch opened flat with the roof of the car, the ice delivery system could move straight along the top of the cars. And when the hatch is open and the ice machine is dropping the ice into the bunker, you don't need a worker on top of the car to guide it and to control the flow of the ice. So you don't need the hatch platform there either. So that got us here. Now, I made an error putting this one together, but fortunately it was right here at this point I caught it. Does anyone see, and you can raise your hand or holler or something, and we'll cover it in a minute, what the error is. The hatch cover handles correctly go towards the center of the car. So the worker opening the hatches is standing on the roof walk. He's not having to stand on the rooftop itself. So the hatch cover handles go towards the center. I put this one on incorrectly, but since I caught it, it was corrected prior to painting. Another thing I like about cars, if they're not all one paint scheme, and if the paint colors are pretty much isolated to different parts of the car, I can paint without masking the whole car. And then if necessary, in case of these refrigerator cars, the only masking necessary is after the orange was applied, I had to mask for the black stripe down there at the top where it joins the roof. It's the only masking I had to do on this car. If the car is all one color, you build it and you paint it all at once. If there's more detail to the paint job, then you get into a lot more masking. But fortunately, this one was simple. And there's the completed car. And I even went so far on this one as using the original prototype photograph to try and model the weathering itself on this car. There's the black and white photograph from the book that I sourced for the particular car. And there's the weathered car in black and white. Now, it's anybody's guess what the other side of the car looked like. I have no clue. So I just kind of ad-libbed that one. But I think I did a pretty good job on even, besides the modeling, even matching the weathering on this car. And this is car 8996. This is the first time I finally got to do it because I thought about it a lot. I modeled the drain hoses on this car too. Now the Intermountain cars come with a cast plastic piece you glue up in there. You can either glue it up open or closed. These particular cars had what looks like a rubber hose for a drain. And that's what I used on my car. It's just a piece of wire insulation. The other car, 9037, considerably easier to model. The only changes on this one were, this one must have received one of the new end frames to the USRA underframe because it didn't have the big chunky block there. So all I had to do was take that big chunky piece of metal off of there because it wasn't visible on the prototype and add in little tabs that I could facilitate by putting my hand grab irons on it. So that was pretty much the way the modeling effort went on that one. Didn't have to modify the door, didn't have to modify the hatch covers. I don't know why it keeps jumping when I touch the mouse. There's that model, there's the model of the little piece of iron that when the hatch is open would support it in the near vertical. There's the platform the worker would stand on. There's the original 5-foot swing door, pretty much standard as the car was built, just a couple mods on that one. Almost to the end here, guys. On my shelf, I've got things to do, like probably many of us do, and I found an Intermountain kit for a Pullman standard 50-foot double-door boxcar. I have no recollection of why I have this kit. It's there, and that's all I know about it. The Santa Fe Railway Historical and Modeling Society, through various resources, have produced a series of books that cover all their equipment, freight, passenger, and work, up until the merger into the BNSF, which occurred in 1995. There's an example of one of them. This one is titled Furniture and Automobile Boxcars. There's a separate book for boxcars, one for tank cars, one for what they call open top cars. They've lumped a whole bunch of them together in there. And they even go into the passenger world. They've got sleeping cars, they've got chair cars, they've got head end cars. Anything you'd want to look at, super source of reference material for building any kind of model you might want. So I went through the boxcar book and I went through the furniture and automobile car book to see if I could find anything that matched this Intermountain kit. And lo and behold, in the furniture and automobile car, I found an FE37 class. There's the numbers, built by Pullman Standard, built in 64, so it'd be around in 67. They built 570-ton capacity, some basic dimensions, car kit there, and what kind of trucks went under the car. I said, well, that looks like a match for this particular car kit. There's the prototype car, nice, super good color picture of the car. And here's, once again, the folio diagram. I was able to obtain one of these that gave me all the detailed specifications for weights, dimensions, type hardware, and equipment you'd find on the car. And so using this and the photograph, I have other photographs too, using this, I was able to create a model of the car. A couple things needed changing though. The sill contour on the model car didn't match what the kit was. It actually had a slightly lower profile than shown here, which I've replicated here, and it went all the way to the end of the car rather than ending about where the first riveted side panel was. So that was one mod I had to do. That's easy. That's just a piece of strip styrene. You file off the part of the underframe that doesn't look, side sill that doesn't look right, and you glue the styrene in. And the other was it had a cushion underframe. And Santa Fe had shock control pretty much as their type underframes, other than those Duriers that I showed you. I compared accurate models, some from Nick Molo at Molico, who makes super accurate models of cars, and other known accurate models and photographs and plans of cushion underframes. And using parts from Molico, I was able to create a shock control cushion underframe for this car. Little strip styrene for scratch building parts and the cast parts for the rest of it. And there's what it all looked like put on the bottom of the car. You can see the cushion underframe. In the center there is the actual shock absorbing device. Right there is a return spring that helps center the system after the shock has been kind of mitigated there. I have Pullman standard extended draft gear coupler pockets. I have the the side sill with recontoured correct to match the prototype, and all the details that would go on the ends of the car, including walkover platforms, dispatch type grabs, shortened ladders in a couple cases here. And there's a photograph of the completed car with all that work gone into it to create an FE37 car for the Santa Fe. And they only made one of these. This was enough a challenge by itself. And lastly, another video to show you this year. The whole reason for this is nostalgia. I model 1967. This is pure steam engine stuff. And I decided for nostalgia, the Santa Fe got out of the steam engine business about 1956 was their last revenue run of steam locomotives. Brought them out for things like the Potato, the Spud Rush, and for helper service on a couple occasions. Otherwise, they were 100% diesel railroad from that time on. First thing I acquired was an original production Broadway Limited 484, and it had at the time what was called the QSI electronic system. That took care of all the sounds the locomotive made, and it took care of the operational parameters, how it ran, did it accelerate fast or slow, and what was the max speed, things like that. The thing I noticed in my research along the way, a lot of locomotives, like a 282 would be called a Mikado, and a 464 would be called a Hudson, and up and down that white system of designation. Apparently the Santa Fe never called the 484 a Northern. They always called them 484s. Other 484s were Niagaras and you know, pick a name, any name. That was fine. That was a nice operating locomotive. The QSI system made it very easy to operate and control using DC alone. And you programmed it with directional toggles flips. You didn't need a fancy programming system for it. And I was very happy with that on my DC railroad. Then Broadway Limited came out with another Santa Fe classic locomotive, a 210-2. But by that time, they installed what they called the Paragon 2 system. 210-2s were built for heavy freight drags and were built for helper service on Santa Fe over heavy grades like Cajon and Raton and places like that. The Paragon 2 system, on the other hand, could be programmed and operated with a DC system, but it was very comfortable and awkward to use. Russ Weiss even invited me over to his place one day. We put it on his railroad and we went through some programming work with it there, and it ran splendidly. I took it back home, put it on my DC railroad, and it wasn't worth beans. So I kind of just let it sit at the side there. I didn't do much with it for quite a while. What I really wanted to do was to create a setting where I could run the 484 and the 210-2 either double-headed or using one as a lead locomotive and one as a pusher locomotive. 484s were kind of dual service. They ran passenger trains, and they were used in freight service too, kind of interchangeably. The two different parameters that these locomotives were programmed and operated under prohibited that. They would not work together no matter what I did. So I went back in history and watching carefully on eBay and a couple friends searching for me. I found one of the original Broadway Limited 210-2s that had the QSI system, but a bunch of detail errors. They were significant appearance errors in this locomotive in the first way Broadway produced them. The steam chest didn't have drifting valves on them. The cab was wrong. It didn't incorporate a second seat behind, a length for a second seat behind the fireman so the head and brakeman could ride up there. One of the drivers was completely wrong. It was a spoke driver rather than a box pop driver. Other small detail items made it pretty much non-acceptable, a non-starter as a Santa Fe detailed locomotive. But I dug into it. And from the new 210-2, I ripped out the QSI system, everything that had to do with it. And I took the original 210-2 QSI, ripped the Paragon system out of the new one and installed the 210-2 QSI system. And that locomotive, besides having a correct appearance, was now fully compatible and operational on a DC railroad to my satisfaction. Some of the things I had to work with, the operational characteristics, for example, the 484 had 80-inch drivers. The 210-2 had 63-inch diameter drivers. If you take 17 inches and throw pi at it, that's 4.5 feet difference in one revolution of that wheel as to how far the locomotive would advance down the rails. 4.5 feet per revolution. The two models had the same motor, and as near as I can determine without tearing them down, they had the same gear train to transfer the motion of the motor down to the driving wheels of the locomotive. So if you think about 4.5 feet distance each time a wheel went around that I had to account for, it took a lot of programming effort with the easy to use, from my perspective, DC friendly QSI system. I finally got both locomotives to work together, and it took quite a while. I still appreciate Russ is trying to help me out with it in the beginning. On his railroad, it worked great. On mine, it didn't. So now here's an example of what it looks like when they run these locomotives. This is a 1.3% grade going up the backside of my railroad. This is the desert Southwest, perhaps in New Mexico, where my railroad represents. I have the 484 leading a 48-car freight train up the grade, and the 210-2 in the back acting as a pusher, rolling. This was filmed with a handheld tablet, so I don't think Cecil B. DeMille or the Oscar Group is going to give me an award for this one. But you can see what the result is. There's the 484 leading the train, up 1.3%. The first three cars you're going to see might look familiar from some of the last things I showed you. They just didn't have all the complete decals on them yet. There's the one of the FE37s right there. And here comes the 210-2 at the back end pushing. And as it drives further away, we'll see the back end of the caboose. There's a set of those lighted marker lamps. Santa Fe used amber forward to the side and red to the rear on their marker lamps. All righty, Roo. I'm finished. Ready to take questions, comments, suggestions, complaints, gripes.
Waka waka, thanks. Thanks very much, Bruce. Any questions from anyone? There's only one more. There are a couple of comments about the scale car, and then when you were talking about it's like when you're talking about the kit, like where did this come from? Mark Hedge had a comment that said kits breed when hidden. I think they breed whenever they're put down somewhere, whether they're hidden or not, Mark, but that's okay.
That's for the Intermountain 50-foot boxcar. Yeah.
Yeah.
I looked at the shelf one day and there it was. I knew it was there, but I just never paid any attention to it. And one day I said, why do I have this? And what can I do with it?
Anybody with any questions?
Bruce talked about the scale test cars. I remember years ago with the Southern and so forth that they had them, they used them because they were required to, but they just about freak out every time they would put one on the back of a train. And it had to be right next to the caboose where the conductor and the rear brakeman could keep an eye on it because they didn't trust them. They were too short. Even though they were scale test cars, they were pretty light in the grand scheme of things. So they didn't let them get out of anywhere other than the rear end of the train, where they wouldn't get lifted off the track in a curve or something like that. So, yeah, and like I mentioned in the comments, you talk about no brakes. Well, besides the brake shoes, then you get into brake valves and pistons and reservoirs and all that stuff there wasn't any room for on a scale test car. So they just said, never mind about the brakes.
I didn't think of that aspect of it, but it makes sense. Just a big chunk of weight. I've seen photographs of modern day test cars. They might take a flat car or something and pour a chunk of concrete on it, or I've seen some others that were built as test cars, but they look more like freight cars rather than just a little mini stubby thing.
Yeah, most railroads use the same scale test people that truck stops and stuff use, where they come in with a big heavy duty truck and use a winch off the back to basically unload weight right onto the scale.
Oh.
and check it that way, rather than fool with the scale test cars and all that sort of stuff.
Yeah. Hey, Bruce, I want to say, thank you. Always impressive. After hanging out many, many weeks with Steve Lesher, that I can appreciate all the detail that you've talked about, that you put into your cars and so on. That a lot of times, if we go to fudge on something, you'll say like, well, it's just you and me that's going to know. And I said, well, maybe Bruce and Mike, so. But it's really nice when you like I said, especially some of the cars that Steve has done that are on, and you that are on the layout now, that all the detail that really does make it come alive. So I can appreciate that.
Thank you for the compliment. Thank you.
And I think that's a wrap, Bruce. I'm not seeing any questions in chat, and other than, hey, great job, very well done, impressive, and so forth. And of course, as always, it was. So thank you again, and we'll think about maybe next June, tap the calendar here and put you on there, and we'll have part 3 perhaps, you think?
Well, I've actually got some more I've completed that I could put together for another presentation.
Well, there we go. There we go. Righty, well, I'm sure Russ will be hollering at you for that. So with that wraps up today's meeting. A little longer than usual, but a lot of great modeling from our presenter, and of course from all y'all with the open loads as well. We will see you on July 11th next on Zoom, unless you're on the Division 8 board, in which case I'll see you next Thursday. Or if you want to join us for the board meeting and become board yourself, you can holler at any of the board members. We'll give you the login stuff and so forth, and you'll just have a wonderful time. So until then, happy modeling and be safe out there. Thanks all for joining us today.